Imagine waking up and heading into work as a graph neural network scientist. The day starts with a fresh cup of coffee and a quick scan of the latest research papers, because this field is moving fast. Graph neural networks, or GNNs, are at the heart of your work. Unlike traditional neural networks that process data in grids or sequences, GNNs are designed to handle data structured as graphs. Think social networks, molecules, or even transportation systems where everything is connected in complex ways. Your main job is to design, build, and improve these GNN models so they can learn from the relationships and patterns hidden in graph data. You might be working on a project to predict how proteins interact in the human body, or maybe you're helping a social media company recommend new friends by analyzing the web of user connections. Sometimes you're focused on node-level tasks, like predicting the role or category of a single node in a network. Other times you're looking at the bigger picture, trying to classify entire graphs or predict new connections that might form in the future. A big part of your day is spent coding, usually in Python using frameworks like PyTorch or TensorFlow. You're constantly experimenting with different GNN architectures, graph convolutional networks, graph attention networks, or even more cutting-edge models. When things don't work, you dig into the data, looking for noisy or irrelevant connections that might be throwing off your results. Sometimes you develop new techniques to make your models more robust, like teaching them to ignore misleading edges or to better handle graphs that change over time. Collaboration is key. You work closely with domain experts like biologists, network engineers, or cybersecurity analysts because understanding the real-world context of your data is crucial. You also spend time making your models explainable so stakeholders can trust the predictions. You're always thinking about scalability. Real-world graphs can be massive with millions of nodes and edges. You design your models to handle this scale sometimes by training on smaller subgraphs and transferring what you learn to larger networks. You also keep an eye on the latest research because new methods for making GNNs faster, more accurate, or more interpretable are emerging all the time. At the end of the day, being a graph neural network scientist means living at the intersection of theory and application. You're pushing the boundaries of what's possible with AI, helping machines understand the world's most complex systems, and making sure your models are not just powerful but also robust, transparent, and ready for the real world. Thanks for watching Career Chronicles UK. See you in the next video.